Viewers, I might as well do a current test on this thing. This jaws needs quite a lot of current to work. So see if the volts are right. Okay, it's putting out more there. This is the this puts about 20 volts, I think, if I remember. Last time I checked, about 20 volts the output. So I got a full battery. Yeah, current's not too bad either. Got a quick non-tripod test here. That's on high. Good bit of torque for what it is. That'll make a decent bloody power supply for this drill. A quick benchtop power supply, so when I do a teardown, instead of using that, which is weak for really hard to undo screws, it stops that completely. If I come across a stubborn screw, I use this one. Got plenty of torque at low speed and battery. Virtually running on 50%. Not bad at all. Of course, the other UPS transformer one, that's a lot more power for this, but the voltage isn't quite enough. It's only 12 volts. This needs 18 volts. So. Sweet, it works quite well. Okay, viewers, I might as well do a teardown of my multimeter. I haven't really paid much attention to what the inside of this looks like. This is a pretty much an Extech clone, so I've watched a lot of Dave's EEV blog and watched a lot of his videos regarding cheap multimeters, so I wouldn't expect much inside this one. This is only a $20 meter. So yeah, not the right leads for it either. I've been probing bloody 240 volts with these leads, and really shouldn't be doing it because these aren't proper category what is it, Cat 6 leads. So I was going to buy some good Cat 6 leads off eBay, but not for this multimeter. Alright, I'll set the tripod up and see what this is like inside. I'll pull the cover off. There's a little warning on the back here. Meter must not be connected to high energy sources which have transient voltages greater than 1 kV. This includes the 240 volt mains. I'll get my little screwdriver out. I can start pulling this apart. Yeah, this still has the original batteries in it, so I haven't needed to pull this apart unless I need to change the batteries. A little bit of a shield there. That spring goes on it, acts as a ground. Golden power, super heavy duty battery. I might have pulled the batteries out so I don't probe nothing and short nothing out. Okay. There's a beeper. Little piezo buzzer there. There's the current shunt, so I want to do some current measurement in the circuit. That's what actually takes the 10 amps, so it's only rated for 10 amp max. Fusion's got some protection on the case. It's got some MOVs. And the main chip there. Really not the best, but for 20 bucks a page for it, I suppose it was not bad for the price. I mean, it's been pretty good so far. It hasn't buggered up, but I haven't got a decent multimeter to compare this to, so I don't know how really accurate this thing is. I don't know what burn these capacitors are, but this thing looks like it's bulged out the side. It still works alright, but it's bulged. Chong capacitors. It's kind of impregnated at the side, that one. Yeah. 25 volt, 4.7 microfarad. Got some crap on the solder there. The solder mask got all crap on it. But there you go. I suppose it's not the, yeah, it's more advanced for the compared to other $20 multimeter teardowns I've seen. I suppose it really isn't too bad for the price I paid for it, but again I wouldn't trust it. But it's been pretty good. That just goes in there, the battery holder sits in there. But if this thing buggers up, I'll buy a Fluke. That'll be my next multimeter. Alright. Do a current measurement. See how much power this light bulb uses. Positive in there. Light bulb in series with a multimeter, so the multimeter can measure the current. Sit that there. Power on. Must have the wrong one connected there, boy. Gotta go on the common. That helps. There you go. Yeah, I forgot to plug this in the common. There you go, that's how you do it. 4.92 amps, and it's obviously in reverse polarity there. It's pulling 4.8 amps. What other loads I could try? Let's try this drill. I don't know if the multimeter's going to handle this. Through the multimeter, so it's negative from the lead to the positive of the drill. Power on. Do I check the LCD is on? Doesn't pull anything. Amps. 6.5 amps out first. Didn't like that. Yeah, definitely supplies more than 10 amps this power supply. That's why it was beeping. It only hold 10 amps. I won't go any more than that, otherwise it'll pop. But there you go. This drill definitely, obviously, pulls more than 10 amps. Which means that power supply, I don't know how much that would be. It's short, probably at least, I don't know, it'll be probably at least 12 to 15 amps short circuit this little power supply then. That's pretty good. I can power some decent stuff with that. Okay viewers, before I start to pop this, I might take out these diodes. I'm a little bit short in 1N4004s. I'll keep those. The rest will pop. I've got plenty of little resistors and these capacitors on those TV boards. So are the inductors. The diodes are least common, so I'll take those. I haven't got any of those in stock. Very common rectifier diodes. Okay viewers, I've just got some more goodies. These are 1N4001 diodes. I thought they were 1N4004. Either way, I'm short on these. And these all came off those circuit boards still attached to those flybacks that Billy sent me. Some more add to my spare parts box. Let's try and pop the rest of this stuff for low voltage. 20 volts popping things. Let's see how we go. Let's try this cat. Obviously not enough volts. It's not going to do anything. 63 volt rated. Yeah, not going to do anything like that. Inductor. Yeah. Not enough current. That thing was at full load. Alright, I'll get my bigger power supply out. Let's see if this increases my bandwidth. This one will increase my bandwidth for sure. The circuit breaker will pop, so let's see how much this little inductor can take before it pops. Blue to tracer. The inductor takes it quite well. The inductor's getting warm. Hasn't tripped the 10 amp breaker yet. That's what I call inducing a lot of current in an inductor. It's open circuit. Oh, I've stripped it open with my fingernail. Yeah, it's open circuit. It's popped. Little one still got some, there we go. That's it, once that blow of smoke there popped. Yeah, it popped. Let's try the other two inductors. Oops. Oh, let's burn out this last inductor. There's not a couple on there, the smaller ones. There you go, smoke coming out. It's amazing, I'm not even pulling. Oh, listen, even flames. Didn't trip the 10 amp breaker, it's not even bloody warm. There we go, extra low voltage is just as fun. A lot safer to pop things with, as long as you got plenty of current. But beware of flames. Yep, blew that open circuit. It's amazing, under 10 amps to pop those little inductors. I'm not running for much current at all. Got one last one here, let's pop that one. Alright. I think there are little contacts there. Yep, hear it humming. Yeah, it's quieting down now, so it's burning out. It's taking a while. Pop the resistor. Dead short. Yeah, that inductor wasn't quite as interesting. Good thing the circuit breaker is there to protect the transformer. Yeah, that resistor's open circuit. Let's try our next resistor. I bet it can't resist it. No, it can't resist it. What, that transistor? It popped. 2N, oh that's still hot. 2N2222. It popped. Not open, but it's short inside. Blowing up traces and under 10 amps. Oh, those inductors, the ferrite cores of those inductors retain their heat quite well. Blew the tracer up. Oh, I see. This breaker, I heard a little click and had reduced current. It was partially open. Interesting, as it got warm. Yeah, blew a trace. I'll let the circuit breaker cool down. Interesting. Blow them like a fuse. Bang. So fun. I should be wearing safety glasses doing this too. Pop. The 30 inductor and that capacitor is a bit, that tracer there can handle a bit more current because it's a lot more copper in that. Yep, blow it like a fuse. That's fun. Viewers, that's enough for now. The rest can be finished off in the microwave. That's one way of getting the copper off a circuit board. Viewers, that'll be enough for now. Thanks for watching.